Welcome to Decarbonizing Today, a deep dive into the Edmonton Metro region's role in addressing the global climate crisis. In this episode, we're here with Corwyn Bruce, the Director of Project Engineering with Heidelberg Materials, and Adam Chalkley, the Director of Low Carbon Development at Enbridge, alongside your host, Brent Lakeman.
Today with me are really two leaders within the CCUS ecosystem in Alberta. So Corwyn Bruce from Heidelberg Materials, leading their carbon capture and storage project, and Adam Chalkley with Enbridge. So great to have you both here. I know we want to talk a bit about collaboration, but maybe before we do that, we'll just get you each to speak a bit about your role within the CCUS ecosystem. For Corwyn, if you can go first.
Yeah, sure. So I'm Corwyn Bruce. I'm the project director for the Edmonton CCUS project for Heidelberg Materials. I have a background in CCS. One of the early adopters of CCS. Worked on Boundary Dam. Looking to do our my second project and the first project for Heidelberg here in North America.
And Heidelberg is certainly one of the companies that is looking at carbon capture and including a range of technologies.
Yeah, no, absolutely. So Heidelberg is very committed to sustainability, and Heidelberg has actually made a goal to capture and store 10 million tons of CO2 by the year 2030. And so the Edmonton project here in Edmonton is certainly a major piece of that. We're already building the Brevik facility in Brevik, Norway. That one's going to hit mechanical completion here before the end of the year, and we're going to be storing CO2 from it early in 2025. We also have another 6 projects that are sort of running in parallel with the Edmonton project at various stages of development, kind of around the world. So Padeswood in the UK, Mitchell in Indiana, and a number of others in Europe as well.
Sure, and I'll come back a bit later to how the company is looking at these various sites and maybe how the Edmonton region is fitting into that discussion. So Adam, with the Wadman project with Enbridge, maybe you can just talk a bit more about that CO2 storage initiative that you're leading, and also maybe also some of the collaborations that you're seeing with other partners like Heidelberg Materials.
Sure, yeah, thanks for having us, Brent. Adam Chalkley, Director of Low Carbon Development at Enbridge. It's great to be here at the 3rd edition of Carbon Capture Canada and be able to kind of see the progress that industry's been making, I guess, from the first edition of 2020 when Enbridge first announced and was really happy to be able to talk about being one of the first 6 hubs to be awarded pore space in Alberta's pore space award process, or competitive process. And so yeah, the Wadman Carbon Storage Hub is a transportation and storage infrastructure that's being developed in the greater Edmonton area in conjunction with our partner Heidelberg Cement. So they would be the anchor project for this. Some unique attributes about our project is it's well situated, close to a broad array of emissions in the greater Edmonton area, including the Alberta Industrial Heartland as well as Heidelberg. And we have 5 Indigenous partners also in this project. So Lac St. Anne, Métis, Alexis, Alexander, Enoch, and Paul First Nations. And they have an opportunity once completions happen to earn or to own up to 25 to 50% of the project. So we're, for us, it's both groundbreaking in terms of Indigenous participation, which we think is really key to the success of, infrastructure projects moving forward, but also, really excited to be at the cutting edge in terms of providing transportation and sequestration solutions for projects like Heidelberg.
Sure. And I really want to speak about that partnership opportunities. You're both here, so really recognizing the partnership between your two companies. You've mentioned the First Nations involvement as well. And maybe if you could, each of you just speak a bit about, how that comes together, these types of partnership opportunities around CO2 hubs between emitters, storage facilities, other types of partners like investors, First Nations partners. So maybe Corwyn, if you can just go first about how we saw this partnership actually come together several years back.
Yeah, for sure. I mean, so we launched the Edmonton CCS project in about 2019, and with the first feasibility study that we looked at. And of course, one of the things that we did as part of that was assess where we were going to do our CO2 storage. So we went out with an expression of interest, looking for interested parties that potentially could serve our storage needs. Ultimately, Enbridge, with their successful application, was one of the hubs that was closest to us, and being developed by a world-class partner like Enbridge. And so that's something that Heidelberg looked at as a way of basically de-risking the project so that we could take, some of the transportation and storage risks and move that off site to others so that we could concentrate just on the capture and that infrastructure install. So I think it's the opportunity, obviously, to have good close storage, which of course is why there's so much CCS potential here in Edmonton that Enbridge had, and then the experience and the drive that they had to deliver large infrastructure on pipeline and subsurface as well. And so that sort of fit as a good marriage for us to let us focus in on less of the problem rather than the whole problem. And I think that's what we've been doing. Of course, we have touch points between us. I mean, we're providing CO2 at a certain specification and a certain pressure and these sorts of things. So there's certainly things that we need to collaborate on. But it's been very good for us to simplify our focus, at least for Heidelberg Materials' point of view.
And how about from the Enbridge perspective, including emitters, but also again the First Nations partners, and what makes a good partnership, and what is everyone looking for in this relationship?
Yeah, well, maybe to step back a bit and why we're in the Wabamun area, and then we can kind of delve into the collaboration pieces. This isn't new for Enbridge. Enbridge has been involved in the development and interested in the provision of CCUS infrastructure for quite a long time. Although I think there's a recent resurgence post 2020 across broader industry and a lot of newcomers in the space. We were actually part of a project in the early 2000s, several projects that focused on the Wabamun area, including Project Pioneer, the Alberta Saline Aquifer Storage Project, as well as the Wabamun Area Storage Project. And so when the competitive process came up and we started looking around, we looked at a couple things. One was our history and our understanding and our experience in that area, and it was a natural fit to build on it. The other one was, what the emission sources were around there. And, I think we started talking to Heidelberg early on. And one of the reasons is because they were a first mover. If you actually look back and look through the media and the announcements, Heidelberg started talking about this in the news and the media in 2019, long before heightened interest in this space. And the other thing that we looked at as Heidelberg as a partner is cement and what it means in the world of decarbonization. To steal Corwyn's thunder and his punchline, cement or concrete that is made with cement is the world's second most used material after water. And when you start understanding what the concentration levels are of CO2 in cement and what the alternatives are, which are very limited, you quickly realize that it's critically important that cement be decarbonized as a high priority as opposed, as compared to the other range of things. And so we really saw, I think the value and the importance and understanding of what it was that Heidelberg was trying to do, that they were a first mover. They weren't following a fad. They were absolutely a leader in this space. In terms of the relationship between Heidelberg and Capital Power, I mean, one could say, well, Enbridge, you're simply a service provider to Heidelberg, and we could kind of go to our traditional kind of paradigms for doing business. But the reality is that we're trying to do something very difficult here. We're trying to break new ground, and in order to do that, both sides need to be vulnerable and open. And we have what I would call an extremely collaborative, I would describe the nature of our relationship as a partnership, because there's no way to make progress in this space with anything but, I call it, very open and transparent problem solving between the two of us. And so I think that's really great. Same with the Indigenous part is on the collaboration side is being able to go to them with just an idea and not have everything penciled out like we traditionally did was a big change for us in terms of our approach. Like, Enbridge is the type of organization that really likes to have things bolted down. We know exactly what we're doing, and you can't use that approach in this new space. And so we had to rethink about, okay, we're going to go and see these Indigenous partners, and we're really not sure what we're doing, but we really valued the opportunity to get in there early and have them participate from the ground level, which is a real change in thinking for us. And then more broadly, I think collaboration is extremely important across the broader industry, because we need to share learnings across the board, because it drives efficiency, it increases speed, and it drives out risk. So learnings from our competitors, similar projects that are being developed around the world. I mean, collaboration right now is the key to success for all of this.
Sure. And I just want to talk a bit more about the project, particularly Heidelberg's project, really the size and the significance, the scale of it. So I guess, what does this really mean for the cement sector? And also, I think to an extent, the hub itself and the size and scale of the hub, which has a very large geographical footprint. So maybe we'll start on the capture side with Heidelberg and really that significance of this project from a global perspective.
Yeah, sure. So if you back up from a global perspective, I know Adam already stole my line, but certainly, cement is 7% of the world's GHG emissions come from the production of cement, and of course, concrete is the second most used material in the world after water, and so it's something where there's no alternative, right? So there's no solar cement, there's no wind powered cement, there's no renewable cement. It's going to continue to be part of our building. The other thing is that cement itself, the production of cement, the chemistry itself is where 2/3 of our emissions come from. So we start with limestone, we heat it up, and 2/3 of the emissions are actually limestone turning into lime, which is the first start of our process. And so that makes cement a hard to abate sector. So here we have a product that is essentially irreplaceable, and has a inherent high footprint regardless of what fuels you use. So that really leads it to being a good option for post-combustion carbon capture, because we have the fuel emissions and the process emissions mixed together in one piece, going off to the facility. And so if we talk about the significance of the Heidelberg Edmonton project, I think we start with Brevik. So Brevik is going to capture 400,000 tons of CO2 per year. That's about half.
Brevik is just help us location-wise. This is back in Europe, in Norway.
Yeah, sorry. Brevik is in Norway. It's about 3 hours south of Oslo. And so what that project's going to do is it's going to capture 400,000 tons of CO2 per year, and that's about half of the flue gas off of the back of that existing system. And of course, they're a little bit limited because they have to use only heat that's recovered from the cement kiln, because there isn't a huge source of natural gas or something like that that's available. And so that is going to be the first large scale project that Heidelberg actually has in service. The Edmonton project is going to be the first one that treats all of the flue gas from the existing kiln, and so that's going to make us a first on that line. I think one of the things that's really interesting about cement is cement plants are different than energy infrastructure, where CCS has been applied forever, right? Everything to date has always been energy infrastructure, and so this is stuff that is hyper reliable, runs day in day out, and really has no dispatch requirement. Well, we in the cement sector, we have a market that we're trying to fill. And so our cement kiln is not necessarily able to run or need to run all the time. And so one of the things that we really is really pioneering about the Edmonton CCS project is we've combined a combined heat and power plant with the facility. We're going to treat the emissions from the kiln and the combined heat and power facility at the same time using the CCS plant. And then when the kiln has to come down, whether it's because of a market slowdown, or whether it's because of reliability or whatever, this facility is going to stay on, and it's going to basically run in power mode. So in terms of the numbers, when we're running with the kiln on and the power plant running at full load, we'll capture about 4,085 tons of CO2 per day. When the cement kiln comes down, we stay on power mode, and we'll capture about 1,600 tons per day, which represents 98% of the emissions in that flue gas. So we have this dual mode plant, which I think is really good for hard to abate sectors and stuff that's outside of the energy industry. And I think it's a model we're going to see move forward. Now the next piece that goes with it is the cement kiln in Edmonton. We recently put in an alternative fuel system. And so what we're doing is we're replacing about 50% of the natural gas we burn to heat our kiln with waste and refuse derived fuel. And so what's neat about that is not only does it direct a material away from a landfill, which of course is a future issue, but a significant portion of the carbon that's in there is actually biogenic in content. So this is coming from wood demolition waste, these sorts of things that were in the air at some point. And so basically, we get to the point where, because we capture 95% of the CO2 emissions, and because 10 to 15% of our CO2 emissions are biogenic, we get all the way down to net zero on our entire site. So the site's actual footprint is going to be very close to zero because of this biomass that comes in.
And just from a relevance, I guess this would be the world's first commercial scale net zero low carbon cement facility.
Yeah, I mean, yeah, absolutely. It'll be the world's first net zero carbon facility without using offsets, without using anything. It's just chemistry and the process on our site. And actually, we'll be also probably the lowest emission natural gas generation in the world as well, because we'll be exporting in the range of about 70 megawatts that we don't need to run our cement plant and our CCS plant. We'll be exporting about 70 megawatts onto the Alberta grid from a site that has no apparent emissions. And so that'll be emission-free power that's base load and reliable and that kind of stuff. So that's also a big part of our offering.
Sure. No, it's so exciting for the region. And Adam, with the Wobman Hub, I get excited about it because we often talk about carbon capture and storage, focused around the industrial heartland, but your CO2 hub is much larger in breadth, I guess, looking at the west side of the Edmonton region, where we have counties like Parkland County, for example, where we've seen different industries locate. So providing some opportunities, I guess, for CO2 storage in different regions that maybe we haven't always been thinking about. I know it goes back to Project Pioneer and some of the earlier CCS projects, but maybe what's the relevance both from the I think the different geological zones you've been looking at, as well as the regional scale of Wobman?
Yeah, no, certainly we have a fairly large area in terms of lease. It's about 280,000 hectares and involves two distinct geological zones. To give you an idea of what we're targeting for Heidelberg cement, we're targeting something called the basal sandstone unit, which is basically the lowest storage formation before you hit the basement, which is essentially granite and unusable. And in our lease space, that formation sits up to 3,000 meters deep. So we're talking really far down there. And so we're doing a lot of work. We've drilled 2 evaluation wells in there, and there's a lot of data collected, baseline studies, to ensure that we fully understand the formation before we go in there, because it needs to be done safely. And at the end of the day, Heidelberg is contemplating $1 billion+ investment, and whether or not that investment works or not hinges on whether or not we can accept that CO2 at the end of the day. So it's really important that we get this right. It's a key part of the puzzle. I will say, geological modeling and understanding increases over time, including through in-service. So we're hyper-focused on making sure that Heidelberg's right now. And putting Heidelberg in service will further unlock our understanding about how much more can we take. We're very confident that we have rights that are more than able to support Heidelberg's project, but Heidelberg going in service will actually help us further understand how much further we can go with that. I think one of the things that you have here, and it shouldn't be lost, if you got 2 very, very focused companies that have been at this for a while, right? As I said earlier, Heidelberg announced their project in 2019, and we've been at it for several years too. And we're not spreading ourselves thin. We understand that we need to be focused, and if we can't get this one right, everything else doesn't really matter. I think about the discipline and the investment that we've both made at risk. Corwyn, you're probably worth talking about technology selection, right? And Enbridge recognizes, hey, we have a partner here who is advancing 2 of the most proven technologies in the world, right? Everything is about cost risk profile in this thing, but
Yeah.
Yeah, and I was going to ask you specifically that question about looking at different capture technologies. I know you've been testing different approaches, and maybe you can just speak about where you're at and where those technology decisions are when they'll be made potentially.
Yeah, for sure. So the Edmonton CCS project, this is post-combustion carbon capture. And so there are carbon capture projects around the world, but there are actually very few that are post-combustion, right? And so we have to look back to, Boundary Dam and Petra Nova are the 2 examples here in North America at the same kind of scale that we're talking about. And so when we looked for partners to do this project, we said, okay, well, let's use the 2 most experienced partners in the world, right? So we're using Mitsubishi Heavy Industries, who's partnered with Kiewit as their EPC engineering firm, and so that's one of our technology tracks. And then we're also using Shell and Technip who have partnered together. And of course, that's the same technology that was used at Boundary Dam. So both of these companies are currently engaged in a feed study that gets us all the way to basically a durable offer to complete the plant. So we have that going on. We've selected obviously partners that have built at million ton scale and actually know the full challenges. I think that's one of the problems we see with people who haven't done it before. There isn't that experience in terms of what hurdles might be up the road. So we've de-risked it that way. The other thing is we've actually put pilot plants on our site, and so one of the learnings that came out of Boundary Dam was that over time, over longer periods of time, the contaminants and stuff in the flue gas, like the particulate and these sorts of things, can actually play havoc with the chemistry. And so that was one of the key learnings from Boundary Dam, is that once you get to 2,000 or 3,000 hours of operation, you start to see side reactions and other stuff happening within your amine and the chemistry process. And so that is one of the reasons that we're doing this long-term piloting on site, so that we can take both of these technologies, put them behind our exact flue gas with the exact particulate we have, and see how it runs in the long term. And we can validate the durability of the amine. And then the second piece is we can validate the residual emissions or the emissions that come out of the facility. And so that's really important in terms of de-risking, right, is choosing good partners and then testing their stuff on your actual kit. That is key for de-risking our Heidelberg project.
Great. Yeah, and great to see some of those companies right here at Carbon Capture Canada as well. So really seeing how these players are all coming together. Just to build a bit off that, so just as you're looking at different capture technologies, Heidelberg Materials, I think you mentioned, is looking at different sites. So can you maybe just speak to what does that competition for sites look like globally for Heidelberg, and maybe what makes the Edmonton region so interesting, hopefully from the perspective of the company, to move forward towards a final investment decision down the road?
Right. I mean, the first thing you do when you're looking at carbon capture is you got to find the storage, right? And so, it's kind of a no-brainer to come to the Edmonton area. We've got Shell Quest that's been established. We have the Alberta Carbon Trunk Line, Sturgeon Refinery, Nutrien, right? So there's CCS projects that are here that are storing CO2 underground and using it for EOR, right? So they're putting the CO2 away. And so that is the key thing that we look at around the world. So if you look at our portfolio of projects that we're developing around the world, they are either near places that you can do geologic storage, or they are near hubs or infrastructure that can allow storage, right? So the Brevik project is an example. There is no actual storage right there, but the Northern Lights project has shipping container or shipping ships that will take actually the CO2 around the North Sea and put it into depleted oil fields, and that's one of the things that let that project go forward. Here in Edmonton, of course, we have a great area around us, and of course we're partnered with Enbridge, and so that's a good storage solution. The one in Indiana has locally available good geology, and so they're looking at developing that storage themselves. So certainly storage is one of the first things. That's the first thing you need to tick off the box, and then the other thing is government and financial supports, and also the legal infrastructure and all that stuff you need to be able to do CO2 storage. And so those things really all come together in Canada. The investment tax credit, the Alberta Carbon Capture Incentive Plan really help us on the capital side. And of course, we've got all the regulations in place in Alberta or being developed in Alberta. And they're really, really focused on getting everything we need to basically get the permits we need to store the CO2 and to get the value that's turned out of the offsets that are ultimately be created. Sure. So yes. Yeah.
And maybe even the workforce itself. I mean, you mentioned your background on carbon capture as well. So, we're getting more experience with these types of projects, both in Alberta, Saskatchewan, places like that.
And so Heidelberg has actually assembled a team. I have a team of 15 people that are working on the Heidelberg project, specifically with Heidelberg. We also have a number of contractors that help us. So WSP is our owner's engineer. We've already talked about the two technology providers. We actually also have two technology providers for our combined heat and power plant and all the stuff that flows down through it. So we're really keeping competition alive in all parts of the project, and so that's quite a bit of overhead, honestly, to carry around, and so we need a fairly big team to do that.
Sure.
I think the other thing to talk about in the Edmonton region is, of course, a carbon capture plant looks a lot like an oil refinery. It looks a lot like a gas battery. These are basically gas treatment facilities with lots of piping, heat exchangers, pumps, and in Alberta we have that capability here. We have the capability to modularize it and do that construction efficiently, and so that's another benefit for us here in the Edmonton region is we can use all that infrastructure that was built up to build out the oil sands. That same infrastructure works for us in CCS, so that's also a key component of the benefit of being here in Edmonton.
And that gives me a bit of a segue, back to Enbridge as well. So, think more generally about CCS for your companies. You're an energy company, Enbridge. You're used to moving things around. I think of the pipeline work that Enbridge has done. You're a cement company, but where does carbon capture and storage kind of fit into that balance now between sustainability, economic prosperity, and maybe what are your thoughts, your company's thoughts on moving forward in that space?
To build on the Edmonton kind of opportunity here, you're talking to two international companies. I mean, Enbridge has substantial infrastructure in five countries, and Heidelberg, many more. And you've probably heard on many other podcasts along the way, capital has no borders. It free flows,
Right.
and it goes where it works the best. And the reality is, Canada, and in particular the Alberta Industrial Heartland or the Greater Edmonton region or Western Canada, all still has some very strong attributes, which is why you're seeing Heidelberg pick this location as one of its key things. We often get compared to the Gulf Coast, and why would I build in the Gulf Coast versus Alberta is quite often a comparison. And people are still electing to do projects here. I mean, Dow's net zero ethane cracker is a big project. Alongside with that, you've got Air Products building a new project here. You've got Linde building a hydrogen plant for Dow. And these are all world-class projects, in large part due to things like having the CCUS regulations in place. It is a leading jurisdiction. CCS is a big building block for attracting projects in this area. But it goes broader than that. I think, you touched on labor. We touched on the availability of skills and knowledge here. There's also other, I think, interesting factors that really are going to drive continued development in this area. I mean, from a gas price perspective, we have some of the most competitive natural resources pricing in the world, period, even relative to the Gulf Coast. We also have, and I think this is an emerging theme that is becoming more and more apparent to Canadians as a whole, is like geographically, we are very well situated to certain parts of the world like Asia that have energy security problems and have their own, decarbonization challenges. And so, there's a lot of really good attributes to this part of the world. Is it perfect? No, but these other jurisdictions also have their own unique challenges as well. So I think we'll continue to see lots of development here, and projects like ours, the hub, and Heidelberg will further unlock future development in this area. Why Enbridge in this? At the end of the day, we're an infrastructure company. We move 30% of the crude oil produced in North America. We move 20% of the natural gas consumed in the U.S. We're the largest gas utility in North America. We have a lot of experience building large-scale capital projects that have a lot of technical, regulatory, social challenges with them, and we understand the importance of doing it right and cost effectively. And so, we're bought into energy transition. We want to be a part of it. We think it's important, and this is a really great project to, I would call it as foundational for Enbridge, both from a energy transition perspective, as well as I touched earlier, also in a social perspective of community acceptance around this, Indigenous partnerships. It really is a multifaceted opportunity for us to participate in.
And certainly early projects that companies will expect to replicate further down the road. So again, back in the Edmonton region, being that early test bed for these projects to get them commercial scale examples that then will be useful elsewhere in the world. Maybe that's certainly maybe from the Heidelberg perspective.
So for sure. I mean, Heidelberg doesn't want to be, it's doing CCS is just a tool to the end, right? So Heidelberg is on a path to be a net zero company, right? And so we're on a path, for the Edmonton project, we're going to be selling CO2 offsets and that sort of stuff to help the business case. But ultimately, as quickly as possible, we're transitioning to selling high value, low carbon building materials. And so that's where Heidelberg sees itself in the world, is building itself out as the low carbon building material supplier for cement, aggregates, and these sorts of things. So the Edmonton project, although interesting, is just project number 2 after Brevik, and it's the start of a very long chain of a full decarbonization of our entire portfolio. And so it's not just CCS; it's also using supplementary cementatious materials, doing recycled concrete paste. There's a whole bunch of irons in the fire that Heidelberg has outside of CCS in order to decarbonize our end product. And to that point, I mean, even in terms of CCS, so the first projects that are being deployed at world scale are using post-combustion amine capture, because that's what's available, and that's what you can do at this million-ish tons per year type scale. But we are in the process right now of building an oxy-fuel system that will be combined with an amine capture system, and that's going on in Bulgaria right now. So Heidelberg has a number of activities, not just on the deployment of large scale, which you need to do to get that experience of operation and compression and storage and all that kind of stuff, but we're also building out utilization technologies at the smaller scale to see how those newer technologies maybe can help us reduce the cost of decarbonization for carbon capture. So we've got a full portfolio worldwide that's all heading towards one goal, which is in essence being decarbonized fully by the year 2050.
Great. Okay, well, great. I think we've covered most of my questions. If there's any other messages that either of you have you'd like to get across, but
I think it's important maybe to quantify the magnitude of this opportunity. To date we have 5 commercial carbon capture projects in Canada. I'd say 3 large, with the definition of large being kind of 1 million tons and above, and then 2 sub 500,000 ton projects that in aggregate add up to slightly over 4 million tons of carbon capture installed capacity operational in Canada today. This project, has the potential to increase that by almost a third. It's a big step change. If this came on tomorrow, it would have a meaningful impact to Canada's, total carbon emissions reduction relative to where we're at today as a single project.
Yeah, well, that's great context to provide about these very large-scale projects in the Edmonton region. So I want to thank Corwyn, thank you, Adam, for participating on this one, and I hope we have a rest of a good, successful conference as well, and look forward to hearing more about these projects moving forward.
Thanks for listening. Stay tuned for our next episode of Decarbonizing Today to continue exploring how decarbonizing tomorrow starts today in the Edmonton metro region.